Earth, a unique planet, restless and dynamic. Continents shift and clash. Volcanoes erupt. Glaciers grow and recede. Titanic forces that are constantly at work, leaving behind a trail of geological mysteries. One of Earth's most intriguing mysteries is the presence of a huge arc of geological destruction surrounding the Pacific. It is known as the Ring of Fire. 3/4 of Earth's volcanoes are situated here, and 90% of all earthquakes also occur along this line. Over the last 200 years, disasters here have claimed over 1 million lives. The Ring of Fire is one of the most extensive zones of destruction on planet Earth. Its most visible features are the hundreds of volcanoes that line the shores of the Pacific Ocean. They form an arc which extends 25,000 miles from South America along America's northwest coast to Alaska, and then down through Russia, Japan, and Southeast Asia, all the way to New Zealand. Cataclysmic eruptions have occurred here throughout history. August 1883, Indonesia. The Krakatoa volcano blew itself to pieces, creating the loudest sound in recorded history. June 1991, the Philippines. Mount Pinatubo blasted debris 22 miles into the atmosphere. Suffocating ash swamped over 2,500 square miles. And in May 1980, Mount St. Helens caused $1 billion of damage. The ever-present threat from these volcanoes makes it essential for scientists to understand the forces that power them. The investigation begins here, in Alaska. This land of rugged beauty marks the most northern extreme of the Ring of Fire. 75% of all the volcanoes in the United States are situated in Alaska. In the distance, the volcano soon appears.
There's Augustine volcano over there. It's going to be a perfect day to visit.
Augustine is a stratovolcano, the type of volcano found all around the Ring of Fire.
Stratovolcanoes are quite unique in that they are shaped as beautiful cones, and Augustine is a perfect example of that.
Augustine last exploded in January 2006, the most recent of 7 eruptions here since 1935. Over the years, solidified lava flows have gradually built up on the volcano's flanks.
This lava is more thick when it comes out of the volcano, and its thickness will have an effect on how it runs down the slope. The thickness or viscosity of lavas can be shown in a number of ways. Hawaii lavas are quite runny. Honey is a perfect example of that. If you have the volcano putting out Hawaii-like lava, it's going to run quite easily down the rock. Whereas if you have something more like these blocky lavas, they're going to be a little bit more like peanut butter. They'll still run, but the viscosity is much greater.
The viscosity of lava is primarily determined by the amount of silica it contains. Silica is the most abundant mineral in Earth's crust.
The more silica, the thicker or more viscous a lava is likely to be.
Hawaiian lava contains little silica, so it's runny and produces a relatively flat landscape. But Ring of Fire lavas are rich in silica, making them sticky and less able to flow, creating tall, cone-shaped stratovolcanoes.
Volcanoes have lava that is thick, things don't move through them very well. And bubbles of gases can build up.
Molten rock called magma contains dissolved gas. But as this magma rises, the pressure decreases. This drop in pressure means bubbles of the gas begin to appear, just like opening a bottle of soda. If the magma is runny, these gases can safely escape. But in sticky, silica-rich ring of fire magma, the gases can get trapped, often with terrible consequences.
It's like trying to have a bubble move through peanut butter. It won't happen quite so easily. So there's a lot of pressure that builds up. And once that pressure builds up, it reaches a point where it can't take all that pressure anymore.
The result? Giant explosions caused by the catastrophic buildup of gas inside the molten rock. This is the reason ring of fire volcanoes can be so dangerous. But it's not usually the initial explosion that kills. It's what happens next.
Those explosive eruptions can create plumes that go up for tens of miles.
When these plumes run out of energy, they can collapse back down the sides of the volcano in a superheated avalanche of ash and gas. With temperatures of 1,300 degrees Fahrenheit and speeds over 100 miles per hour, these flows destroy everything in their path. A terrifying consequence of the explosive eruptions caused by gases building up inside thick lava. Deep underground, rocks are hot and semi-solid. It might seem that the presence of water would cool them down. But that's not what happens. This water, which is under huge pressure, alters the rock's structure and causes them to melt, forming plumes of magma. This molten rock soars up to the surface, building giant volcanoes. Without water causing magma formation deep underground, these ring of fire volcanoes would simply not exist. By sampling the gas coming from these fumaroles, scientists hope to discover the source of the water which causes the magma to form. The gases contain carbon-12, a type of carbon that comes from living organisms. The specific levels of C12 found here are the unique signature of tiny sea organisms called phytoplankton. Billions of phytoplankton live in the ocean. As they grow, they absorb carbon-12 into their cells. When they die, they fall to the bottom, forming layers of sediment. In this way, their carbon-12 is transferred to the seafloor. Intriguingly, scientists have found this same carbon-12 pouring out of volcanoes all around the Ring of Fire.
Volcanoes of the Cascade Range have carbon dioxide that's very rich in carbon-12, and it's almost like you're cooking oceanic sediments that are rich in phytoplankton down deep beneath these volcanoes to generate the carbon dioxide you see coming out the top.
Seafloor sediments are getting into volcanoes, and these sediments contain seawater. This is the water that causes the rocks to melt below the volcanoes, forming magma. The presence of jumbled oceanic rocks 20 miles from the sea is evidence that something remarkable is happening at the bottom of the ocean.
The fact that you have this mixture of rock types here is evidence for the seafloor moving.
Geologists know that only an enormous process called subduction could shift these mixed ocean sediments here. Subduction occurs when the seafloor moves and slides down under the land. As it descends, the top sediment layers are scraped off by the land like a snowplow scoops up snow. They're pushed up into a huge mound of mixed up rocks. The Chugach Mountains were formed in this way. The seafloor, loaded with water, now continues down into the earth. This is how seawater gets deep underground, where it creates the magma plumes that build the Ring of Fire's explosive volcanoes.
Where we're at right now, the Pacific is subducting beneath us to the northwest at this northern part of the Ring of Fire. It's about 20 miles beneath our feet right here, but if we were to go off that way where the volcanoes are, it's about 60 miles beneath our feet there. And so as it goes to the northwest, it subducts and then brings water and sediment into the earth. That ends up causing melting in the mantle, and then that melt rises as magma to volcanoes.
This process is the engine that powers the Ring of Fire's killer volcanoes. But deep underground, the Ring of Fire hides another, even more deadly secret. Earthquakes that can destroy entire cities. 90% of the world's quakes occur in this narrow band around the Pacific, often with disastrous results. Sumatra, September 2009. A giant earthquake left more than 1,000 people dead. More than 9,000 people were killed by a massive magnitude 8 quake that shook Mexico City. And Alaska, March 1964. North America's greatest ever recorded earthquake near Anchorage. This quake was so powerful, ground movements were observed 4,000 miles away in Florida.
Hiked in, thrashed through the alders, the Alaskan jungle up to here. We're probably 25 or 30 feet above sea level at this point. And what we have here is a beach. I mean, this is basically a perfectly preserved, high-energy beach environment like we were looking at down on the shoreline.
This inland raised shoreline runs for hundreds of yards, parallel with the ocean. It's a key piece of evidence, and it can only mean one thing. The land itself must have recently risen up out of the ocean, taking the entire shoreline with it.
It means that there was an event that was essentially an instant in which this region was uplifted to this elevation and made this here. This has to have been a result of a big earthquake.
The massive earthquake here not only lifted the land out of the sea, it also caused a wave of destruction, devastating nearby Anchorage.
It was a magnitude 9.2. It was the second largest earthquake ever recorded on Earth. It was just enormous. It lasted 4.5 minutes of ground shaking.
What happened throughout this region offers evidence of the type of quake that makes the Ring of Fire so dangerous.
So we know from this kind of earthquake that occurred here in 1964 that this was a thrust-type earthquake, or even there was a fancy term, megathrust earthquake, because it was so big that occurred right here. And this is a result of the slippage of one piece of rock over another, or one underneath the other.
Megathrust quakes like this are the most powerful on Earth and are one of the great dangers of the Ring of Fire. If they occur under the ocean, they can generate killer waves called tsunamis. On December 26th, tragedy struck when an enormous underwater megathrust earthquake off the Asian coast generated monster waves. The coastlines of 14 countries were swamped, killing more than 200,000 people. The vast scale of this disaster was a brutal indication of the power of megathrust earthquakes.
So this is the vault where one of our seismic stations lives. This is one of the many seismic stations that dot the state of Alaska.
Several thousand seismic stations like this exist, all the way from Alaska down to California.
And this whole system together monitors any kind of seismic activity, any sort of earthquakes throughout this whole area. In Alaska, we're looking at about 1,500 earthquakes every month. And you take all of those together and you start to see patterns. They map out a ribbon of earthquake activity that follows all along the coast.
This ribbon of earthquake activity extends all around the Ring of Fire. But it is what scientists can see below the surface that is most revealing.
If you look at it from the side, you see that actually the earthquakes that are happening close to the ocean tend to be shallow, but as you go inland, they're deeper. And they create this dipping feature that starts out in the ocean and then dips down beneath the continent.
This giant dipping feature provides conclusive evidence for how the megathrust earthquakes are generated. The earthquake epicenters exactly follow the path taken by the seafloor as it moves down underneath the volcanoes. Earthquakes are triggered as the rocks slide past each other down into the earth. It is this subduction of the seafloor beneath the land which creates the Ring of Fire's lethal megathrust quakes and builds its explosive stratovolcanoes.
So all of these observations, the volcanoes, the line of seismic activity, the big earthquakes at the interface, all of those are part of one system. They all tie together and are interrelated.
The journey to understand why the Pacific Ring of Fire is so volatile has revealed the critical role of subduction, which pushes the seabed deep down into the earth. In Alaska's Prince William Sound, investigators search for where the seafloor is vanishing below the land. Reynolds' research shows that all around the Alaskan coast, the seabed is relatively shallow. But farther out towards the open ocean, the readings change dramatically.
So in general, around the world, when you go out from land, you cross over a relatively flat shelf, down the slope and into the deep ocean basin, which is very flat. But around the Ring of Fire, as you go out from land, across the shelf, down the slope, instead of going directly into a flat ocean basin, you go across a very deep trench. These trenches are the deepest areas on the planet, and the one around Alaska reaches approximately 21,000 feet.
These giant features are called subduction trenches. The largest are deep enough to swallow all of Mount Everest. They mark the exact spot where the seafloor disappears down into the earth, the process that jolts the land in megathrust earthquakes and forms the volcanoes that make the Ring of Fire so dangerous.
The Ring of Fire is named for these volcanoes that circle the Pacific Ocean. But offshore of the volcanoes, wherever you have a chain of volcanoes, you also have one of these deep ocean trenches.
The location and shape of the Ring of Fire is determined not by its famous volcanoes, but by the position of these deep subduction trenches miles out in the ocean. And by mapping the location of all the trenches in the Pacific Ocean, scientists have made a further, even more significant discovery. High-tech imaging has made it possible for scientists to visualize the Earth drained of its oceans. This reveals that these deep trenches outline the edge of a giant rock slab, or plate, that makes up the entire floor of the Pacific Ocean. This huge Pacific plate is one of 14 plates which cover the entire surface of the planet. Subduction occurs where this plate rubs against one of its neighbors, producing the line of volcanoes which extends all around the Pacific.
This GPS antenna allows us to measure point positions per day of where this spot is.
A network of these GPS antennas across North America provides evidence for the monumental forces which power the Ring of Fire.
By combining all the data of these GPS, we're able to see that North America is actually moving.
The entire continent is moving westwards at about 3 inches per year. This movement is possible because the Earth's crust rides upon a hot, soft layer of rock called the mantle.
Well, the mantle is so hot and it's such a high pressure, and the temperature is hotter as you get towards the center of the Earth. That's going to want to move out and convect, just like a boiling pot of water. And so it creates a convection current coming up to the surface, which then drags along those plates on top.
These phenomenal convection currents force the Pacific Plate into its neighbors, driving the process of subduction.
As the plates get dragged by the mantle convection currents, they impede upon other plates. One has to give, so one dives down underneath another, and then the trapped water from its ocean sediment escapes and melts the upper-lying mantle, and that creates hot magma that rises to the surface and creates the volcanoes that form around the Ring of Fire.
Offshore, the seafloor is swallowed down giant subduction trenches. But despite millions of years of subduction, the area of seafloor remains roughly the same. Geologists could only assume one thing. Somewhere far out in the ocean, volcanic activity must be creating new seafloor rocks, replacing those destroyed here during subduction. Scientists realized that if volcanic activity was constructing new seabed, the surrounding water should be warm. A column of rock pumping out superheated water. This is a black smoker. Measurements of the water around these features have found temperatures in excess of 750 degrees Fahrenheit. This heat comes from magma welling up from inside the planet. It was a discovery that provided the evidence the scientists needed. These volcanic marvels mark the location of giant features called mid-ocean ridges. At these ridges, on the bottom of the ocean, powerful convection currents in the mantle separate Earth's plates, allowing lava to spill out onto the seabed.
New oceanic crust is constantly being formed out on the mid-ocean ridges. That crust moves away from those ridges toward the edge of the continents where we're located now.
In this way, the seafloor is constantly renewed, replacing material destroyed by subduction at the edges of the ocean. These mid-ocean ridges exist at the bottom of every ocean on Earth. They provide a never-ending supply of new rock, keeping alive the entire plate tectonic cycle.
Well, this is a planetary scale process. This is the planet itself circulating, and the rock and the magma from deep inside the Earth welling up to the surface, forming this crust. And then that crust dives back down into the Earth at the subduction zones, at the trenches. And it's mixed back into the solid Earth.
So great is the power driving this system that experts see no end to the constant movement of plates around the planet. But over the coming billions of years, the ongoing movement of plates will redraw the map of the world.
The Pacific Plate is moving, and things on it ride with the plates that are being subducted. So, for example, the Hawaiian Islands are moving up here to Alaska. Parts of California are moving up here to Alaska. Baja California is moving north here to Alaska. So apparently Alaska is a popular place to be. It'll be the resting place of all these things.
So the map of the Pacific will slowly change, driven by the immense force of subduction. Subduction creates the magma plumes which build the region's explosive volcanoes. Subduction powers the violent megathrust earthquakes that shake the region, leveling whole cities in seconds and causing killer tsunamis. Violent eruptions of explosive blocky lava build the Ring of Fire's famous volcanoes. Mixed rocks from the seafloor found miles inland are evidence for the process of subduction that builds the volcanoes. Raised shorelines are evidence for giant megathrust earthquakes caused deep underground by subduction. And GPS plots provide evidence for the immense convection currents deep in the Earth which drive the entire system.
The energy that drives this whole convective system is really without parallel on the Earth. There's nothing else that we can compare to as far as the amount of energy and the force that moves the continents around, compresses them against one another, drags one down beneath the other. Really just awesome forces.
These forces are unstoppable. And while the shape of the Pacific will slowly change, for millions of years to come, explosive volcanoes will continue to line its shores.